Yeah?
You know the guy from Princess Bride?
The guy from Princess Bride?
Is what brought us here together.
My
We're here
that one?
It's something like that, right? It's something similar
Yeah.
to physics. But you can make a joke based on that.
Molecular formula.
Empirical Formulas is what brought us here today.
All right. So obviously this lesson is about percent composition. All right, everyone turn around, face the front, please. Thank you. All right, so this example is determine molecular formula from percentage composition. So the example is this. A compound has a percent composition of 40% of carbon, 6.71% of hydrogen, and 53.3% of oxygen. What is the empirical formula, and what is the molecular formula given the actual mass is 120 grams, or thereabouts? So we have multiple steps here to do. Now, if you're unfamiliar with determining empirical formulas from percents, all right, it's not that tough. What you have to consider is that percent is usually out of 100, right? That's what percent means. It's out of 100. So you could just say this is actually 40 grams out of a total of what should be 100 grams. Okay? So we don't know if we actually have 40 grams of this, but because it's 40%, we know that that could be the mass, as long as the other percents are related.
And should we drop the 1 on the hydrogen? I think it's 6.7.
Yeah, okay, so we'll use these exact masses because that's what we're given in this question. Okay, it doesn't always have to add up to exactly 100, but yeah, if you're given the percentages in the question, just use those. I appreciate that. What does this add up to? Yeah, 100.01. Yeah. 100.01. Okay, that's given in the question. Just use the percentages in the question. It's not your fault. So then this is 6.71 grams. That's a good question though. And this is 53.3 grams. And that should add up to 100.01 is what we actually get, but we'll use those numbers. Okay, that's fine. So, percent composition. Okay, so actually, here's where you actually would take this into account. You would add these up. They should add up to 100.00, but if they do add up to 100.01, that's the total that you're going to use to find the to find this out. So you don't need the total for this one. No, you don't. All we need to do is we need to find the moles now, right? So let's go to moles here. So grams, how do we find moles? We multiply or divide. What do we do? Yeah, divide by grams per mole, right? So for the first one, it's 40 divided by 12.011 grams per mole. What's that going to be? 40 divided by 12.011 is 3.33. 3.33. Now that's going to be moles. Okay, that's going to be moles. And for hydrogen, 6.71 grams divided by 1.00794 grams per mole hydrogen. 6.71 divided by 1.00794. Yep. Okay. So that's 6.657 moles. And you can just use a bunch of decimal places. Don't worry about sig figs till the end. You don't have to worry about that at all. And then finally 53.3 grams of oxygen divided by molar mass is 15.9994 grams per mole oxygen.
1.46.
What'd you get?
1.462.
No, I don't think so. 53.3, not 1.46.
That'd be like
15
3.2.
You almost steered me astray there. That is 3.33? What? That's a totally different number. What happened? Oh, you got it this time?
Yeah.
Okay.
I was always that.
So that's why I don't listen to you. Okay. Just kidding. I listen to you most of the time. 3.33, 137. Fine. Okay, so that's moles of oxygen. Okay. Now, that's 3.33 looks to be the same as this one. So what we should find out here, if this question is set up properly, if we have proper numbers, there should be a ratio between these three, right? So C to H to O. Look at that. Let's divide each of these by the smallest number we see here. 3.33 divided by 3.33 is 1. 6.657 divided by 3.33 is 2. Pretty much double, right? Pretty much exactly double. And then 1 again. So our empirical formula is CH2O. That's the empirical formula, kind of phase 1 of this question. Are we good with that? Any questions about that first part? No, we're good? Okay. So these are the grams here, and yeah, don't worry about the 100.01 for now. Just take what you're given in the question. Okay? Just use that. It's fine. Because again, the decimal here is going to be so close, that's not going to really matter much. Just take what you're given in the question. Now, the molecular formula. Okay, so we're given that the actual mass of this compound is 120 grams. Okay, so again, this was percent. It has nothing to do with moles. This percent was only in mass, right? That percent was only in mass. So 120 grams is not the same as the percent composition by mass. Now we're talking about moles here now, okay? So what we want to do is we want to find what is the mass of this empirical formula. So mass of empirical formula is what? Well, that's going to be pretty easy. That's going to be 1 times the mass of carbon, 1, plus 2 times the mass of hydrogen, plus 1 times the mass of oxygen, and that's going to be 12.011 plus 2 bracket 1.00794 and bracket plus 15.9994. 30.026. So the mass of the empirical formula is 30.026. So if this was the actual molecular formula, then our total mass of this in the question would be given as 30 grams. But what is it actually? It's 120.105. So what you do is you say 120.105 grams divided by our empirical formula mass. That'll give us the ratio of what these molar numbers actually are. So what is that going to be? That's pretty much exactly 4. Okay, so the ratio is 4. That means what we should have added was 4 times the carbons and 4 times the hydrogens that we did. So we'll multiply everything by 4 and 4 times the oxygens. Yeah. So whether this is real or not, this is just a question, but here is our actual molecular formula there. Now, any questions or any errors that you see? Yep.
So we don't have to do like H2O and then just bracket. We don't have to bracket for that.
Well, no, don't worry about the brackets. That doesn't matter. If you did C4 bracket H2O 2 or something, that's totally fine as well. If you want to do that, you could do that. Or 4, sorry, yeah, 4.
Good job.
Yeah, if you want to do that, it's fine. One of these. Okay, so that's a molecular formula question kind of from given percent composition. You guys okay with that? Any questions?
No. We have to write a picture to the video.
All right. Okay, are you going to go out of the video with the song? What's the song?
You gotta like louder. You gotta go louder. No.
Anybody?
Commit if you're gonna commit.
If you're gonna commit, you gotta commit.
Lead it, Chris.
I ain't gonna lead it.
Oh, wait, let me think.
No, you don't have time. I'm going to end the video. I'm going to end the video. Yeah, sing in 3 seconds or nothing. What's that? Clap. Okay,
Yeah.
clap. Good job, everyone. Good job. All right. It's a good way to end. We should end that everyone like that.